In this slide we're going to look at exercise set 1.2.3 grade 11s, and in particular we're going to look at the first question on the sheet, which is Slimy and Slurpy crawling toward each other. So we're looking at, if we read the question, it says Slimy the slug is crawling east to meet his friend Slurpy, who lives 45.0 centimeters away. Slimy has a speed of 0.85 centimeters per second. Now, if Slurpy leaves his home to meet him at the same time, and he is traveling at 0.55 centimeters per second west, how long will it take them to meet? So we really want to know t, right? What does t equal? And we have to note here that Slimy is traveling east, Slurpy is traveling west. So they're traveling completely opposite directions. One of their speeds or velocities must be depicted as negative to show that it's in the opposite direction of the other. And believe it or not, it doesn't matter which one you pick as negative, as long as you pick them both opposite of each other. So if I assume in my picture here that this north is up, then east is over here and west is here. I'm going to assume that east is positive. Okay? So if we look at Slimy, who's going east, he's going to have a positive velocity then. So we got V1 being Slimy. It's going to be positive 0.85 centimeters per second. Okay. Meanwhile, our other dude, Slurpy, he's going west, so that's a negative direction. 0.55 centimeters per second. Okay. And because when they meet together, they will have covered the entire distance from one location to the other, even though they're meeting somewhere in the middle. Slimy's covering his part of it, Slurpy's covering the other part of it. Together, they are covering the entire distance, which we can depict as delta d. As a matter of fact, that's displacement. We'll call that 1, 2, then from 1 to 2. Okay? And that's 45.0 centimeters. Okay? So now that we know what we know, and we know what we don't know, we need to do some calculations. So right now we have two velocities, and what we need is the total relative velocity of these two slugs. And because they're coming toward each other, then they, in theory, they should look like they're coming at each other faster than they really are, because they're both moving at the other one. So let's check it out. We take our relative velocity equation. So our velocity of 1, 2, in basic terms, it's v1 minus v2. Velocity 1 minus velocity 2. And let's plug in our numbers. I got 0.85 minus a negative 0.55. So in fact, we are adding them. So we will get a larger velocity they appear to be coming at each other at. And if we do our math right, it should come out to around 1.40 centimeters per second. That's the closing velocity of these two snails. Now that we have the velocity, now we have like the average velocity over the course of this whole 45 centimeters. We can plug it into our average velocity equation, which is v equals d over t. In this case, it's v12 equals the displacement from 1 to 2 over total time. And we have these numbers. It's 1.4. We just calculate it. Centimeters per second is the displacement, which is 45 centimeters. divided by t. Now it's just algebra to find t. So t is on the bottom of this fraction looking thing on the right side of the equal sign. So we want to get something off the bottom of the fraction. We multiply the fraction by whatever that is. So in this case, we're going to multiply both sides by t, which will cause that t to cancel out on the right, but it will show up on the left now at 1.40 times t equals 45. We'll just drop the units for minutes and run out of space. And now our last algebraic step is to get that 1.40 away from the t. They're multiplied together, so we divide both sides. Divide by 1.4. Divide 1.4. Okay. And we get t equals 32.1 seconds. And that is the final math number for part A. This is how much time it will take for them to meet. Please don't forget to write your final statement at the end. Therefore, it will take Slimy and Slurpy 32.1 seconds before they meet somewhere along this path of 45 centimeters. That's the end of part A. As we continue with part B, now that we know that it'll take 32.1 seconds for Slimy and Slurpy to meet, part B says, well, how far will Slurpy have traveled? So we want to know, now Slurpy was number 2, so we really want to know the displacement of 2. Oh, question mark, right? Or this is Slurpy. Okay, so let's see. Now in this case, we're not really worried about direction, but we could if we wanted to. If you want to say, well, this now, because Slurpy's going west, I can make west positive. Okay, you can say, okay, how far is he going to travel? Okay, so we look at Slurpy's velocity, that's v2, and we see that it's 0.55 centimeters per second, and we know that the time he will stop after 32.1 seconds, because he will have met Slimy. Okay. Again, this is just an average velocity equation, which is our v equals t over t. In this case, it's v2 equals we don't know d. Well, I guess we're not putting them in yet anyway. d2 over total time. So let's plug this in. Let's move the slide. Which is, I think, this button here. There we go. Okay, let's plug these numbers in. I have 0.55 centimeters per second is equal to d, we don't know, delta d, I guess, over t, which we found out in part A is 32.1. So again, 32.1 on the bottom of this fraction. Let's multiply both sides by 32.1. So I get 0.55 times 32.1 is equal to d. Delta d is what I want. We multiply those together, and we'll see that delta d, or the distance traveled by Slurpy, is going to be equal to 18 centimeters. So, and he was going at a slower rate than Slimy, so naturally Slimy would travel a greater distance than what he does, because 18 is nowhere near half of 45. And don't forget to write your therefore statement at the end. Therefore, Slurpee will have traveled 18 centimeters during that time frame. And we could say done. By mistake here.